Why did you move now? No, why are you moving? You can't play chess now, it's math. Yeah. Why were you were sitting here and then you moved there? Right, people, so let's quickly mark. At number 1, it said write down these expressions, or write down whether these expressions are monomial, binomial, and trinomial. Now, when it's one term, we call it monomial, 2 terms, binomial, and 3 terms, trinomial. So quickly mark. Thank you. Okay, then at number 2, it says find the value of 4x squared plus 10x minus 17 if x is 0. So you'll see at A, I substituted in x is 0. And then your answer should be minus 17. Then at B, they said, what if x is 6? Yeah? No, you could just have written binomial, trinomial, monomial. Okay. Then at B, they said x must be 6. So if I substitute that in, I get 187. And at C, they said x is minus 4. So if I substitute that in, I get 7. Any questions there? Can I skip? Hands up who's still copying. Okay, quick. Did you do homework? You done? Right. Then at number 3, they said they give us the expression 12x squared plus 2x minus 15. Now at A, they asked me how many terms are in the expression. That would be 3 terms. At B, write down the coefficient of x squared, meaning what's written in front of the x squared, and that was a positive 12. At C, they asked me for the constant term. Now, that's the one without the variable, without the unknown, and that was not just 15, but minus 15. You have to have that negative, okay? Then at D, they said calculate the value of the expression when x is minus 1. So all I did is I substituted it in, and then your final answer would be minus 1. At E, they ask us write down the degree of the expression. What do we look at when we want to get the degree? The highest power. Yes, the highest exponent. And the highest power here was to the power of 2, so meaning this would be a second degree. If you just wrote 2 there, it would still be correct. Okay, because I just asked you what's the degree. Yeah. No, if it just said 3, it's also fine. Yeah. Okay, any questions at 3? Okay, then at 4, they said, yeah? Okay, hold on. Oh, my little father, relax. Okay, hold on. I heard it 5 times. Oh, it is a minus 5, sorry. I must have put it in wrong in my calculator. Kom ons sien is so aggro. Okay, right. At number 4, they're asking, are these 2 like terms? Now at A, you will see that over here I had x squared and there x to the power 3. So immediately I can see they're not the same, so therefore no. Okay, then at B, a to the power of 2, a to the power of 2, b to the power of 3, b to the power of 3. So that is why, yes, they are like terms because they're exactly the same. Okay. Then at number 5, they said simplify if possible. So over there, the first thing we have to look at, are these like terms? Yes, because they both have x to the power of 2. And when it's like terms, then I am allowed to go and add or subtract. Did we talk about that? Okay, so 7x minus, x squared, minus 14x squared. Have a look. 7 minus 14 gives me minus 7. The unknown stays exactly the same. It's like saying 7 apples minus 14 apples. Your answer will still be in terms of apples. Do you guys understand? Okay, so when we add or subtract, variables stay the same. That's why we stick to like terms. Okay, it only changes once we start multiplying or dividing. Okay, can I skip? Right. Quickly mark B, C, and D. Just have a look at C. These two weren't like terms. So that is why I give you the expression again. That is simplified. I can't go any further than that. Yeah. Yes, perfect. Okay. Right, so let me just finish copying this one. So at 6a, what we had to do is first get rid of those brackets. Now when I multiply in that that positive, it's not going to change anything. So now I go look for like terms. 2x squared plus x squared will give me 3x squared. Do you guys see this? Am I going too fast? You fine? Okay. Minus 4x plus 4x will give me 0x. But we're not going to write that. We just leave it out. Right? Okay. Then 3 minus 4 will give me minus 1. Any questions there? There's people talking in between. It's very rude and disturbing. Can I skip? Right. So at B, sorry, I didn't finish writing. Okay, so first things first, let's get rid of those brackets. I'm going to send you girls out when you keep on talking like that. Right, so that will just become positive x squared minus 13x and minus 15. So nothing really changes. It's only when that sign is a negative, then it's going to change. Okay, so now we look for like terms. Minus x squared plus x squared gives me 0x squared, but we just leave it out. We don't write anything there. 11x minus 13x would give me minus 2x. And then minus 12 minus 15 gives me minus 27. Any questions there? Okay, C. Can I skip to taking away the brackets already? Yeah? Yes. No, it's when we work with exponents. Anything to the power of 0 is 1, yeah. But if it's 0 x squared, that's actually 0 times x squared. And anything multiplied with 0 would just be 0. So that's why we write nothing. Okay. Right, so over here, like terms. Oh, ek het 'n square gemis daarso. Okay, so 13x squared plus 2x squared will give me 15x squared. Then, normal x's, that x didn't have any other like terms, so it stays minus 11x. And then minus 10 plus 5 will give me minus 5. Any questions there? You guys okay? Okay, again, over here I'm getting rid of the brackets. So plus x squared minus 5 plus 2x squared plus 8x plus 5. Now once we get rid of the brackets, now I need to add, but only allowed to add like terms. So 7x squared plus 2x squared will give me 9x squared. Oh, I missed one. Sorry. 7x squared plus 1x squared gives me 8x squared plus 2 will give me 10x squared. Then my normal x's, minus 8x plus 8x gives me no x. Okay, and then minus 5 plus 5 gives me 0 again. So this is basically what we end with there. Okay, any questions? Can I skip? Or maybe I can fit this, I can fit it in down here. Okay, 7. At number 7 it says, what must be added to that to give me the 7x squared? Now, let's turn it around. Let's say I have this. What must be added to that to give me 7? What would you guys do? You're actually going to say 7 minus the 5, right? Okay, so that same principle I'm going to use here. So I'm going to say 7x squared minus 3x plus 10. And then minus, and this part is important. I have to put it in brackets because it's more than one thing. So I'm subtracting the 5x squared minus 3x. Oh, minus 3x plus 8. So I'm subtracting that. Now, why do we put it in brackets? Because that negative in front is now going to influence everything inside that bracket. So this will now become minus 5x squared plus 3x and minus 8. Do you guys understand? Because I'm multiplying in. All right, so now we can look at like terms. 7x squared minus 5x squared will give me 2x squared. Minus 3x plus 3x is nothing. And then 10 minus 8 gives me, right, 2. Who got that? Good. Yeah. Okay. Can I skip? I assume I can when everyone is talking. Okay, so 8a. Over here it said subtract that from this. So let me just write it out what it should look like. We're going to have 3x squared plus 3xy minus 6y squared and then minus 4x squared minus 2xy plus 6y squared. Now, if you guys get confused, I just want to check, is it maybe written? Okay, have a look at the top of page 71. It says, when you subtract something from something else, always write the part that follows from first. Okay, so whatever's written after the word from, that you write first. Does that make sense? Okay, so if you maybe switch these two around, now at A, please make a note of that. You said no, Lisa. Do you not understand? Are you sure? Do you need me to do an example? Sierra. Okay, anyone else? All right, so again, that negative is going to influence everything inside that bracket. So let's see. The first part will stay the same, so that's going to stay like this. But this now becomes minus 4x squared plus 2xy minus 6y squared. Yeah. Can you see all your signs changing after that? Yeah? Yeah. Okay, now we go look for like terms because we now got rid of all the brackets. So 3x squared minus 4x squared will give me minus 1x squared, but I'm just going to write minus x squared. Then 3xy plus 2xy will give me 5xy. And then minus 6y squared will give me minus 12y squared. Okay, listen, if your terms are just shuffled around, it's fine. You can, for instance, have minus x squared, minus 12y squared, and then plus 5xy. As long as the sign is the same as my term that I've got here. Okay, right, then the last one at B, they say from 9a squared, what? So I know that comes first. So I'm going to say 9a squared plus 4a minus 10. So I knew that came first. Then subtract, so minus, and again, put in brackets, 6a squared plus 3a minus 9. Ooh, Allah. One of you just said you did it in grade 7 already, no? Okay. Okay, so let's go multiply in that bracket. So this will become minus 6a squared, minus 3a, and then plus 9. So now we got to look for like terms. So 9a squared minus 6a squared will give me 3a squared. 4a minus 3a will just give me 1a, or a. And minus 10 plus 9 will give me minus 1. Right, any questions? Yeah? Yeah. 5? Okay, hold on. Oh, no, there. That one. Okay. For those of you that are now waiting for me, you can write multiply and divide polynomials. Okay, so multiply or divide Okay, so what we're going to do now is we're going to multiply. First start with multiplication. Later on we'll divide as well. Right? Now you had some of these in that investigation as well. Yeah? Yeah? That one. Okay? You good? Okay, now, when I give you something like this, 3 and then x squared minus 4x. Okay, what I actually want you to do is that 3 written in front of the bracket is actually 3 times everything inside the bracket. No, do you guys agree? So actually, it's the same as saying 3 must be multiplied with x to the power of 2. And 3 must also be multiplied with minus 4x. Okay. Do you remember this from the test? Okay. So let's go fill in. If I said 3 times x squared, I would get 3x squared. Okay. Now you'll see that when we multiply, your variables might sometimes change. Okay, right, so 3 times minus 4x will give me minus new 3 times 4, 12, not 3 plus 4. There were some of you that did that in the test, no? So Muni Lachi, it could have been you. Okay? Right, so do you guys understand that? Now, I think in the investigation, we said that's the same as 3 times x squared minus 3 times 4x. Wasn't it explained like that as well in the test? No. Go. It's basically what we did. 3 times x squared. Ooh. Okay, but it's basically what we're doing, ne? We're multiplying the 3 with every single one of those terms. Okay. Right, let's do another example. Now, okay, now people, even though I've got 3 terms inside that bracket, it doesn't matter. Whatever's written in front of that bracket must be multiplied with everything inside the bracket. Okay, so what will I multiply with? With minus x. Good. Not just with x, because that minus is a part of the x. No. Okay, so minus x times 4x squared will become minus 4x to the power of 3. Good. Now, x times x squared. Right? Good. Ask. Now, minus x times 2x will now become, oh, yes, sorry. Hold on. Minus 2x to the power of 2. Right, yeah. Yes, then it would have been minus 3x to the power 3. Yes, yeah. Okay, now minus x times minus 1 will become plus x. Okay, are we good? Does everyone understand? Right, can I skip? Yeah, ask. It's fine? People? Okay, so this full minus 1 must be multiplied with everything inside the bracket. So minus 1x multiplied with 4x squared. So first look at the signs. A minus times a positive will give me a minus. Okay. There's actually a 1 written here. No? So 1 times that 4 gave me 4. And x times x squared gave me x to the power of 3. Yes. Okay, then minus x must also be multiplied with a 2x. So minus 1 times positive 2 will become minus 2. And x times that x will become x to the power of 2. Does it make sense so far? X plus x is something different than x times x. 2x. Okay, then minus x times minus 1. So minus x times minus 1 will become, a minus times a minus becomes a positive, and x times 1, x. You good? Right. Can I skip? Can I skip, people? Okay. Now, example 3. What if I gave you this? 4a plus 5b minus 3 times a minus 3b minus 8 times 2b. Okay, now, what we have here, first things first, how many terms? 3. Hoor vir my, ek by. 3, nee? Okay, so, remember when we multiply n, you only multiply n what's written in front of it. So this 2 must be multiplied with a 4a and with a 5b. No. Okay, so let's start with that. So 2 times 4a gives me 8a. 2 times 5b gives me 10b. Okay. Now, why don't I multiply any further? Because my bracket ends there. Okay, so I'm done with that. Now we get to my next term. Yeah? So now, what must be multiplied into this bracket? Not just the 3, but the minus 3. So minus 3 times a will give me minus 3a. And laat ek net my minus 3 times minus 3b will give me positive 9b. Okay, you guys multiply in that last one, please. All right, then minus 8 must also be multiplied with a 2b, and that gives me minus 16b. So can you see now I got rid of all my brackets? Okay. Now I must look for like terms. Yes. So 8a, okay, 8a minus 3a will give me 5a. And then there's no other a's, no? So 5a, then 10b plus 9b will give me 19, minus 16b will give me, ooh, Lulu. Okay, there we go. You fine? Okay, right. Now this was multiplication the whole time. Now let's, Isabel, met ek jou foon vat? Pere, mag jy foon in die klasie? Okay, now, what if we divide? So have a look at the last example. Right, so how many terms do we have at the top? 3 terms. How many terms at the bottom? 1. So am I allowed to cancel out? We can only cancel out when we have 1 term at the top and 1 term at the bottom. So I can't cancel out. But
what if the terms at the top and the terms at the bottom? 3.
No, but it's still, you may only have 1 at the top, 1 at the bottom. So what we can do is break these up. Okay? So can you see they have the same denominator, 4x? So let's just put them separately over 4x. So then I'll have 3x squared over 4x minus 6x over 4x plus 12 over 4x. Do you guys agree? So because now I have 1 term here, so I can cancel out. 1 term at the top, 1 term at the bottom, 1 term at the top, 1 term at the bottom. So now I can cancel out. No. Okay, so if I cancel out, I can take x at the bottom and then take x at the top. So what's left there? At the top, 3x over 4. Right. Then minus. Okay, now I can say take x and cancel it with this x. And 6 over 4 is the same as 3 over 2. No. Okay? That 12 over 4, can you see 4 can go into both the top and the bottom? No? So that will become 3 over, actually 1x, but I mean you can just write x. Does everyone understand? Okay, that's fine. Have a look. Must I go from this one? Okay. Can you see both at the top and the bottom? 2 can divide into both of them. So 2 will go into 4 2 times, and 2 will go in there 3 times. That's how I get the 3 over 2. Okay, then over here, 4 can go into both of them. So 4 goes in once, and 4 goes in 3 times. So that's how I get the 3 over 1x, or just 3 over x. Okay. Yeah. But then don't forget that x must be at the bottom of the fraction, because if you said 3x, that's wrong. Okay. Right. Any questions, people? Okay. Now, in the textbook, and you'll see it at the homework as well, next to that fraction, they specifically said, well, I'll say no. They sometimes show it like this, but in the textbook it was in brackets. X, what does this mean? X may not be 0. Why are they saying that? It's not going to influence any of my calculations. It's just because my denominator here has got an x in. If that was 0, it means it would be, I don't know what, but divided by 0. And anything divided by 0 is undefined, meaning it can't happen. No, it doesn't influence anything. We just have to state that x may not be 0. Okay. No, it's written in your textbook, so I want you to understand why it's written there. Whenever we have a fraction, remember the bottom part of a fraction may never be 0. So that's just why they say x may not be 0. Okay, and at your sums, you're going to have a at the bottom, and then next to that, they just say a is not equal to 0. Okay, so don't let that confuse you. It doesn't change anything. It's just they have to say it. Okay, any questions? Okay, now, I'm not doing an example like that because I want to see if you guys can still remember. There are roots, right, and square roots and cube roots in the exercise. So please remember your rules. Yes, Malcolm, you had your hand up? Yeah, that's your final answer. Why could I not go any further than that? Because they had to be like terms for me to be able to add or subtract them. And they're not. Okay. Other than this one. Okay. I'm going to write it and then let's say, and then because x is my denominator, I have to say x is not equal to 0. Otherwise, if I didn't say that, and x is 0, it means this whole equation can't exist.
So, ma'am, do my example code after the answer, but I put the
comma? No, this is the question. Yeah, and then all you have to do is break it up and say 12x squared over x minus 4x over x, and that we cancel out, so that will be 12x minus 4. Okay, that's it. So it doesn't influence anything you're going to do. I just want you to understand why it's there. Okay, right. Lisa, jy gesels nog die hele tyd. Next time I'm going to make you do the whole class. Right, so exercise 8.2, that is on page 73. Number 1 to 6.